Hello. Good morning. Excuse me. All right. Let's look at this. All right, everybody. I'm gonna check on. I did send them. I did send the CS help desk an email, and they didn't respond to me. I'm sure they're getting plenty. But I did see that someone got on Java last night, which, if you were just trying to retrieve your files or even compile, you can use Java, though that's for the compiler students. But as I said, it does have G++ on there. So let me try to connect. And let's see if Bobby is alive. And if not, I may resort to using what I can. I mean, as long as you don't tell the compiler students, I think it should be fine. As long as you can connect, you have all of your same directories, and it does have G++ on there. So, yeah. I don't think they can get mad at us for that. If all the servers are down, looks like this one's up, so I guess we'll try it. Guess we'll use it for today. And if anyone does get mad at you, which they shouldn't, because they let you log into this anyway, you can always tell them that I said it was okay. And so then they'll come yell at me instead. But this is the only server that's up right now, so we've got to work somewhere. All right, so there's a few things to talk about today. Our main subject for today is exception handling, which is kind of a small subject. In my opinion, it's not the most important subject for this class, but it is something that you should know about. If you're going to be a C++ master one day, and you run into this in your code somewhere, you should at least know what's going on. So we will cover just a little bit of this today. But for the most part, I will not have you do anything from exception handling in your assignments. I really don't do that usually. So you won't have to do exception handling in your assignments. And I may ask you a question or two on the test, but I'll make sure to throw it in the review so you can study it. All right, so that's kind of what exception handling is today. But before we do that, let's see. So assignment 7 code grade will go up sometime today. Assignment 8 PDF will go up sometime today. The comprehension questions are already available, so if you want to go check the due date on assignment 7, I said the 13th, Tuesday. And so then I think I'll do the recursion questions for Thursday, and then I'll make the final project due on the, I think, What did we agree on? Is it the 19th? Guess I should check, huh? I guess I should write that down. Anyway, it'll be due a little bit after. Oh, I'm sorry. I'm saying all of the wrong dates. I'm sorry. Let me repeat that. I'm saying all of the wrong dates. Let me log into Web Campus here. Quizzes. Yeah, I gotta fix that. I was getting a little mixed up there. Getting a little mixed up. So that, I need to fix it. That's good, and that's the 7th. All right, so I fixed that. Thank you for catching me up there. So let me repeat all of that, what I just said. Assignment 7 will be due on Tuesday the 6th, not the 13th. Tuesday the 6th. So that's next week on the 6th. Assignment 8, I'm going to have it due on Thursday the 8th. Assignment 9, the final project will be due on the 12th, as Megisto said. I gotta warm up my tongue today. So yeah, keep those in mind. Those will be our due dates for the remainder of the semester. Is there class on Monday? If there's no class on Monday, I might skip exception handling today. Summer 2 session. Let's see. Isn't July 4th on Sunday? I mean, if it's, I didn't hear about it, but let me check, just so, because I won't have class if there is something. 7-5, yeah. So I guess there is no class on 7-5. Should have been paying attention, huh? Yeah, you're right. You're right. All right, so if that's the case, then I am going to probably skip exception handling today. Let's go ahead and look at our files. You're right. Honestly, I would like to take that Monday off anyway because I've got a whole bunch of stuff to do. But let's go take a look at it. So here's our schedule. Yeah, so I might start on linked lists today. And I'll upload maybe something about exception handling, but I think I'm going to skip over it. Very interesting. Yeah, so I should read this out. No class on Monday. Let me just make that announcement so we all remember. Because that's important. All right, so thank you for that. So if you want an extension for assignment 6, I'm okay to give it, but I might only give like 1 day because we have to keep things moving. All right, so do you want 1 more day? I'd be willing to do that. But I'm not gonna push it too much further ahead because I want to make sure that we're getting our assignments done. All right. Even Christine says yes. Yeah, okay. I'll make it due Sunday with a late deadline on Monday. All right. I'll make it due Sunday with a late deadline on Monday. And I'll have to edit that after class, all right? I'll save that for later. Yes, due Sunday, late deadline Monday. I guess I'll make that announcement as well to remind myself. And then now it's time for operators, okay? So I'm going to start out with some operators today. So is there any of these operators you want me to do? Is there any operators you want me to do? We are... All right, so subtraction in pre++, I think that's fine. Is anyone upset if I do those? Please let me know. I guess we'll start with those. Let's take a look. See what we can do here. So I'm gonna kind of start from, I guess, the skeleton code as usual. All right, so this will be my header file. So this is kind of where you were at last time. This is where you should have been. This is where you should have been last time. Oh, and while I'm at it, I forgot to do this. I'm gonna open up Malwarebytes just real quick and make sure that the auto updates doesn't set us back today. So I also want to make sure that I pull up the right CPP file here. And settings. No, I'm not interested, please. All right. All right, so I've turned off the Malwarebytes thing, so it shouldn't bother us today. All right, so let me just kind of put some enters here. All right, so we'll be down here then. So here, this is just my solution from assignment 4. All right, so this is my CS202 string CPP file, right? And here is my CS202 string.h file. And so what you have to do is come in here and add the stuff, right? So I'm actually going to open the PDF just so I make sure I follow my own instructions. But I do remember roughly what they do. I just kind of want to reference this. So we'll start with a subtraction here. We'll start with a subtraction. And I guess I'll kind of go over both of these. But we'll do this one here. So if I'm going to add this operator to my class, I'm going to do that because I know that that's our header from the PDF, right? And what we're going to do is we're going to take, say, it's going to be something like, we're going to take this minus some operator, or some string, right? Some string. So that's going to be this minus the right-hand side. So in here, we're going to have a CS202 string. And it's okay that it's passed by reference. I think that's how I made it in that PDF, right? Yeah. Not passed by reference, passed by value. That's a pass by value. So I'll just grab this one and bring it in here. And I need to, of course, use my scope resolution operator. Otherwise, things will not be recognized, right? So now we're ready to go. And so what this is going to do is it's going to find a substring within the this object. So the substring is going to be the right-hand side, right? It's going to find the right-hand side string within this. If found, it will delete it from the string. I should say from a copy of the string and returns the copy. Right, so how do we know that this is how it's going to work? All right, how do we know that this is how it's going to work? Well, notice here that this is returning a CS202 string. Notice that it's notice that it's not by reference. So we're going to be returning a copy, and we're actually not going to be adjusting this. Right, we're just going to make kind of a new string, and that's kind of how all of our addition and subtraction operators have worked before. Right, so you guys I know are familiar with this. I kind of talked about it already. But if you have int y is 5 and int 3 is whatever, and then somewhere y equals 3, and you say int z is equal to x minus y, these x and y's are not altered, right? They remain the same. So we're not actually going to change this object at all. We're not going to change that at all. So Cherry asks, are we going to copy the contents of this object to a new string inside the body? Yes, that would be the very first thing that I would do. That'd be the very first thing I would do. There's a few things that we can check for, of course. If you recall that this find substring function is going to return -1 under a bunch of cases, meaning, you know, if the right-hand side string happens to be larger, or if the substring is not found, stuff like that. So before I actually make that copy, I am just going to check this. If I use this object and I call find substring, and I pass in the right-hand side string. Well, actually, you're right. I'm getting ahead of myself here. No, so let's make a copy of this object. So what can we do? Well, let's maybe declare ourselves a return string, and we can use the parameter constructor, right? Does this code bother anybody? So first we'll make a copy. Here's our copy. All right, there's our copy. And then now I'll actually use this one instead. I was getting ahead of myself here. Either one of these works, of course. And we're going to try to find that substring here within the return string. And so if this is actually equal to -1, then I'm not going to do anything. I'm actually just going to return, I'm probably just going to return my return string, right? Let me go ahead and read the PDF to make sure that's kind of what I was talking about, and I'm not saying anything that I wouldn't. Is to remove the, oh gosh, that's a typo, isn't it? It's to remove the right-hand side string from the left-hand side string. Let me make an edit. Put that somewhere in my notes. I see the question in there. Let me just make note of my typo. Okay. So Ali asks, should we be making a copy for all these operator overloads? Well, let's take a look. I would say any of these that return a CS202 string, the answer for that is yes. Now, these pre-op and post-op operators are also going to alter this object, but it will also return a copy of the object. But the rest of these will be returning, I mean, all of them, every single one that has a CS202 string return type is going to be returning a copy of some object. So yes, you should make a copy in all of those operator overloads. Down here in the bools, it's not required. All right, so I'll get to your question in just 1 second there. I just want to make sure. So aside from this typo, everything should be okay. Yeah. So I'll fix that typo. I'll make sure everyone knows that there's a typo in there. But if you recall from assignment 4, Cherry, the find substring function, it's going to return -1 if that substring is not found, right? So I'm going to first just check to see if that substring exists in there. So for example, if we've got Patty, and then we're going to use like AT as our substring, this AT is found right here. So the find substring function will return 1. If our substring is PAT, that's found right there, and so that's going to be 0. But let's pretend we did like TPA. this substring is found nowhere within the string, so it's going to return -1, as if that's not a valid index, right? Similarly, if the substring is longer than this string, it'll return -1. There's a few cases, right? So all this is saying is if the substring is not found, then we can just return a copy of the substring, right? We did subtract that substring from this string, but nothing, we removed nothing, right? Because we didn't find the substring. Other than that, we will have found that value, right? So let me even do this. Right, exactly. If there's nothing there to remove, we're not going to remove it. We're not going to remove it. And you're right, I could have been better at describing this. So maybe I should kind of come back in here and review it just a little bit. And if that's the case, then I'm glad we're extending it, because obviously I was not descriptive enough. So actually, I'm just going to save this value here, so I only have to call the function once. I hope you guys are okay with this. I just moved it outside of that. I moved it outside of that if statement. And then I'm going to do an else here. And let's say this one, we found it, right? So for example, if we're going to take Patty, right, minus AT, we're going to get PTY, right? Because we're going to take out that A and that T. And so the index that we find it at, the index that we're going to find it at will be at 1, right? That's where the, I guess I'll remove that. Well, we're about to use the delete at function, Cherry. If you wanted to do the memory stuff, you're allowed to, but I'm going to use delete at because it's the easiest way, at least in my opinion. So notice that this AT is found at index 1. And so that's kind of where we're going to start. Now, how many characters are we going to delete? In this case, we're going to delete 2. But guess what? Here's kind of the fun part. So say we're going to start with this string here. If I call delete at on A, so right now, let me just kind of put this side by side. So right now, A is at index 1. If I call delete at on A, what will the index be of T after we call delete at? What will be the index of it? It'll be P, T, T, Y. 1, right? So in kind of a fun roundabout way, I can keep calling return string dot delete at the index, right? At the index that we found it. How many times do we call it? Can you guys give me a guess here? How many times would we call this delete at? We don't actually have to alter the index. We'll just keep deleting it at 1, right? And then pretty soon we'll end up here. Just once? Are you sure? Because if we called it just once, we would end up with that. I'm most happy with 420's answer, the size, and Coda, right? That's the size. So we should actually call delete at twice, right? We'll call delete at twice. And that is the length of the string. So if this happened to be ATT, then we'll call delete at actually 3 whole times. 3 whole times. So we'll call it again. I don't know why I did that. Right? So for the length of the string, we'll call delete at that many times. So if it's 3, we're going to call delete at 1, 2, 3, right? Let me kind of put that in a comment here. This will be delete at 1. And then we'll call it again. And then we'll call it again. And then we'll end up with that. Yeah, exactly. That's exactly what I would do, Ali. That's exactly what I would do. So I would say for int I is equal to 0. I is less than the right-hand side, right? That's our substring dot get size or size, whichever one you want. I plus plus, and I'll call delete at on this string. And then after I'm done, I'll call return string. And that should be good to go, I would say. So let's go test it, shall we? Let's go have some fun. I am going to delete this just so I can look at it. We've got a tiny little function here. Not too bad. Terry asks, is the return at return string a keyword? It's not if it's conjoined. So you can take any keyword in C++ that you want, and as long as it's not like by itself, it won't be the keyword. So you can always kind of combine it with something. I could put this if I wanted, and it won't be a keyword. So I just chose that variable name. That's all. I just chose it because that's the string we're going to return. If you prefer to name it copy, that's fine. I'm just indicating that this is a copy, right? So I will kind of develop a little main function here just to test it, because I am interested in that. I think I gave this main file to you, but I am gonna... Do you guys have any questions about that one? We'll do another one after this. Do you guys have any questions about that operator? And I'll kind of give you the next one, but first I want to ask, does anyone know of a super easy way to do this one? Let me see. Does anyone know of a super easy way to do the next one here with the const character? What's the easiest way that we could do the operator minus for the const character array there? So let's do a few things here. Yes, that's exactly what I would do. So let's try a few things. I'm going to just call print string because I didn't do the other operator. So I'm going to say maybe S5 is equal to S1 minus S2. And then we'll call S5 dot print string. And then I'll do this just a few times. And we'll say S5 is equal to, let's do S1 minus S3, and we'll try it again, and then we'll do S5 minus S4, right? So we would make a copy, turn the copy into a string, and then call the first operator. Yeah, roughly. I'll show you. I'll show you so you guys can do kind of the addition operator in the same way. I'll show you. But this one will look like, I just want to make sure we can take a guess. This should be PTY. This one will be PAT. And this one will be just Patty, right? Because we're not going to subtract anything from it. So let's give it a shot. I am here. I'm not in the right directory. All right, works pretty good, huh? So we went over that one. Let me just do the other one for you real quick. Show you what that looks like. So what's the next one look like? Well, it looks like this. Looks like a const character array. Yeah, exactly. You expect anything else from me? I know I might be a little slow today, but I still got it. I still got it. All right, so this one is super easy, all right? This one's super easy. I'm going to do it in one line of code, and we can discuss it, all right? I'm going to return this minus CS202 string. We'll do this one. All right. How about we get a yes or no from the chat that you're okay with this? Or do I need to talk about it a little bit? Does this one bother you? Let me go try it out in main while I'm at it. This should turn a color. Please turn color. I would love to see you do that. CS202 string. Should be okay. So then I should be able to do something like this. S5 is equal to S1 minus, say, P. And then I can do that. And we should see ATTY. All right, so Cherry, that's a great question, and we'll talk about it. Let me just make sure it works right. Make sure it works correctly. And I want you to know that I've kind of designed this homework so much so that you can kind of do that with a lot of the functions, especially the addition one. Yeah, that worked fine. That worked just fine. So that is the subtraction operator. Yeah, this is the subtraction operator. So what does that call? This calls this one. It's kind of like this. It basically calls this dot operator minus, and then it passes in this as the parameter. So basically, Cherry, I dereference this so I can get a type, right? So I can get the CS202 string type, and then I convert this character array into a CS202 string, and then I call the other operator. I call this one. So this is this. That's exactly what this is. This is CS202 string minus a CS202 string. And we already did that function up here, right? And the only thing that's different here is that parameter type. So I just converted the parameter type into a CS202 string, and I called the other operator. Does that bug you? This is kind of like, I don't know, in the copy constructor, when you see something like this. I'm calling the assignment operator here, right? In this case, I'm calling the subtraction operator. I'm calling the other one. I'm calling the other one. I guess I'll leave that comment there. That's a decent comment. All right. So those are the subtraction operators. I'll give you one more. Let me go find which one we're going to do. The pre plus plus. Are we okay with that one? This one's kind of fun. And if we do the pre plus plus, we'll be able to do the post one pretty easily. All right, I'll leave that one for you. But I'll show you kind of how we do this one. So let me make sure that the PDF doesn't have any typos in it. One is the pre-op and the other is the post-op. The pre-op will make a copy of the first character and add it to the beginning of the string. All right, so in this case, we're going to make a copy of the B, and then we're going to turn it into B beans, right? It will also, so what it does is it's actually going to return a copy of that string, but it's also going to affect the original string. So I said if we do a cout on both of these, we're going to get a copy of that string right here, and the original string will also be altered right here. And then, of course, the post-op will do the same thing, except it's going to do it on the last one, right? So basically what I do now, you can kind of finagle it to work the same as the post one, all right? So this is going to be the pre-op. And so this is going to return a copy of the CS202 string operator. This is a plus plus. Now this one's the pre-op. So do I put anything in the parameters? What do you think? Do I put anything in the parameters? I mean, I kind of gave it to you in the PDF, obviously, but I'm checking with you. Nope, that's right. The pre-op doesn't take anything. But the post-op takes the dummy int, right? Let me find it. There's the post-op, right? Post-op is taking the dummy int right there. So this one's not going to take anything. I got to make sure that I get my scope resolution on here. And so what does this have to do? Well, like I said, if we've got, I guess we'll work with Patty this time. If I've got Patty and I call it, I'm going to end up with PPATTY. And so kind of what function do you guys think I could sort of call here? Is there a function that we already have that you think I might be able to call here? And if so, what do you think? There's two of them, actually. There's two that we could use. Yeah, concatenate. That's what I'm thinking of. I would like to use the concatenate here. But we have this problem, and I'll show you what the problem is. So we're going to get our char. It's going to be the copy character. And that's going to be, say, equal to the character array. I think I called it stream here. I'm sorry that I called it stream. This is the char array. Honestly, I should really change it. But let me just show you. When I first did this, I named it stream. All right. So I'm putting a note there for you to not get confused. I called it a stream in my solution. So this is the character array, right? And if it bugs you, I can always do this. I see some of you have been doing this in your assignments, which I'm totally okay with. I'm very happy to see that. And that's the first character, right? That's the very first character. So that's the one we're going to copy. Now, here's the thing. This is a character, right? So if I tried to call concatenate now, and I would pass in this as the first. I would pass in this as the first. Oh gosh, hold on one second. I would pass in, so we're gonna make, let me kind of slow it down here a little bit. We're gonna make a change to the this object, right? We're gonna change the this object. So I'm going to call the assignment operator, right? Because the concatenate function is returning a copy of, say, P plus Patty. I'm not sure what you're asking, Synchro. So if you could please try to rephrase it. I'll do my best to help you. But back to this little bit here. I'm just going to overwrite the this object, right? I'm going to call the assignment operator. That's fine. I already did that one for you. Concatenate will return a copy. And then I want to do this, right? But this is a problem because the concatenate function, if we go look at it, it doesn't take a character as a parameter. Yeah. So Ali, up here, if you go look in your header file, this says char array. This says char array in your file, but I'm calling it a stream for some reason. Ask past, Mr. Petrowski. Ask Mr. Petrowski from the past why he did that. I'm not sure, but that's where it is. All right. So when I say stream, I'm just referring to the character array. So yeah, 420 right says that's where you get stuck, because you can't pass a character to this. You can't pass a character to this. So I'm going to use some C++ karate here. So what are some things we have to work with? Well, I know we have the parameter constructor. I like that. And that makes the CS202 string. So this one takes a const char pointer, right? Now the way this works, it looks for the null character. It looks for the null character at the back of the character array, right? So what if I did this? What if I said I have a character array that's size 2, which is equal to the copy char, and then at the back of it I have a null character, and then here I call CS202 string parameter constructor, and I pass in the array. What do you think about that? I would call that C++ karate. So I'll kind of repeat what I said. I took the very first character out of the character array. I took the very first character out of the character array, right? That's what this is. Sorry. Silly Mr. Petrowski here. And then I'm going to convert it to a character array. So this makes it basically like this. It turns, here's what it does. It turns the character P. This is exactly what this line of code does. So if you have a character P like this, it converts it into this. It basically converts the single quotes to the double quotes. That's what this line of code does, in which you're just going to make a character array. It's a one character string that's terminated by a null character. So that's what that line of code does. And so now I can pass this. I can pass this array to the CS202 parameter constructor, right? And that's going to make a brand new CS202 string. And now my concatenate is going to work properly. It's going to convert this to a CS202 string, and then we're going to concatenate two CS202 strings, and it should work. So let's give it a shot. So that one worked fine, and then I just want to do kind of the exact same code that I did before. So I'm going to see out ++S1, and I'm going to see out just the S1 afterwards. And with any luck, we should see both of them as that. Let's give it a shot here. So you guys okay with that? Did I lose you guys anywhere? I mean, it's pretty kind of simple, right? My goal was to give you, I wanted you guys to use your C++ karate. You know, I want you to do that. I want you to think about how you can, like, expend the least amount of time coding on this project. You know what I mean? And so you'll notice here I'm using something I already coded. You'll notice here that I'm using something I already coded, just as long as I know how to use SLLs. Now, there's one variation called a circular linked list. Circular. I probably did that wrong. Almost. There's a variation called a circular linked list, where the last node is linked to the first node in the list. All right. So you can have a circular, can I do it this time? DLL, and you can have a circular SLL. All right, so in a way, there's kind of 4 total linked lists, but really there's only 2, right? It's the singly and the doubly, and they can either be circular or non-circular. If a list is non-circular, the last element is pointing to null. All right. So how do they work? So before I kind of talk about that, how do linked lists work? So each node will store an element. So a node is kind of an element. A node is an element. Nodes also have to store information about where the next element is located. So that's kind of the thing here with contiguous and non-contiguous memory. So the advantage to a dynamic array, and I'll make a little Excel here. The advantage to the dynamic array using a pointer is that the elements are all side by side. So you only have to know where the first element is, and if you know that, then you can get to all the other elements, right? Hopefully that makes sense. So if you've got your character array here, which will be, say, or we'll do an integer array. And this one is located at 0x0a or something. You only need to know this address. And so when it comes to the contiguous memory, you say, where's my second element? Well, that's 0x0a plus, say, 4 bytes. And here you're at this location, right? Where's my third element at? Well, that's 0x0a plus 8 bytes. Here I am. Now I'm at that element, right? But with a linked list, they're all over the place. So linked lists might look like this. I just want to make an exact copy of it. So this is our block of memory, and it's all located all over the place. This might be 0x, I don't know, CB or something. This might be 0x, could be anything, right? It could be AA. I'm just kind of throwing out random ones here. And then this one could be 0x005B, who knows? So they're all over memory. They're all over the memory. They're not side by side. So this node, these elements, actually have to store information about where each of them are. So in a way, you're going to have these pointers. Let me get some shapes going on here. You're going to have this pointer. And so 3 here is going to be looking at number 2. And then number 2 is going to be looking at number 4. I wish you could make this easier for me. Excel. I kind of want it to come from the node. And then similarly, number 4 is going to be looking at 5 here. So in a way, you've got this linked list where this one is linked to here, this one's linked to here, and this one's linked to here. Now here's the benefit, right? So remember, if I want to add an element to this, I can't just come out here and say this is 6 now, because this memory doesn't belong to me. So I have to go to the operating system. I have to say, no, give me a new strip of memory. Thank you for the new strip. This new strip is now, say, located at, I don't know, some other address. And in this new strip of memory, we have to copy over 3, 2, 4, 5, and then we'll finally insert that 6 at the end. And then what else do we have to do? Well, we have to say, you know what? I don't need this old one anymore, so I delete it. And I send it back to the operating system. Easy as that. Now, how does the other one work? Well, very simply, I say, hey, I need new memory. I don't have to copy anything. I don't have to delete anything. I just have to say, please give me a new node. I don't care where it is, as long as it has an address. The operating system will be, hey, here's your new address. And I'm going to insert, say, number 6. And then the only thing I have to do is make sure that I link this node to this node. All right? So hopefully you're kind of following how this works. And each node, we're going to kind of store information about the next one. Where's our next node? Where's our next node? And so that's a pointer array, and then this is a linked list. So let's see, where was I? Easier in a sense. When it comes to accessing them, though, I'll give you a hint about that. When it comes to accessing them, this one, it's just take this address, add some bytes to it, dereference. I have my element, right? But in this sense, it says, give me the 4th element, please. You have to go, all right, I have to go here. Is this the 4th element? No, I have to go here. I have to go here. Ah, here's the 4th element. So it's not even adding. You're going to have to traverse through this list one by one until you find it. So there are some easier parts to it. There are some advantages, and there are also some disadvantages. So each node also stores an address to the next element. And then I'll put kind of here, well, that's fine. I kind of want to add one little note here. If a DLL, if it's a doubly linked list, each node also stores the address to the previous element. So that's kind of a little caveat there, in that if it's a singly linked list, they only kind of point in one direction. But if it's a doubly linked list, then you're actually going to have another arrow that's pointing back at this one. And then same here, same here, same here. So we'll get into that, all right? We'll get into that. We'll get some examples going on here, of course. So let's see where we are. We're kind of almost done with the notes, and so we're going to spend a lot of time coding the best that we can. We're almost done with the notes here. So just some things to remember. SLLs can only be traversed in one direction. As a DLL can be traversed in 2 directions. And so we'll probably say this. If the LL is going to be sorted, it may be best to use a DLL. And this is because you have an easier way of getting back and forth on the list. A single linked list always needs at least one pointer pointing at the head of the list. All right, so let's kind of break these up now before we get too confusing here. So let's talk about our SLLs. So as I said before, they can only be traversed in one direction. With any linked list as well, there is always one pointer pointing to some node in the list. Usually we call this the head node. All right, so how are we going to access the linked list? Well, similar to a dynamic array, right? Similar to a dynamic array, we need to know the first address, right? So similar to linked lists, we need to know at least one of the addresses. We need to know at least one of them. But there's kind of some problems with that. In that if the SLL is non-circular, the head node always needs to look at the very first element. For all other linked lists, it doesn't matter where the head is pointing, and so we can kind of talk about that a little bit. Maybe I can use my little diagram here. Let's just pretend this is our linked list here. Now, we're going to pretend like we've got a head node somewhere. So we're going to make something here called the head. We're going to give it a body, and let's say maybe it's a yellow thing. And this head is going to point to some list, some node in the list, all right? So in this case, as I said with this singly linked list, it's going to be pointing to the head here. So now every time that we want to access this list, we're going to go into this node, and then we can get to every element by following the arrows. We can get to every element by following the arrows. Now let me ask you this. If this head node was pointing at this node instead, is there any way that we can get to 0x0a? Is there any way that we can get to that element? What do you guys think? Is there any possible way we can get there? No, that's exactly right. So we have a problem, right? This is an SLL right here. This is an SLL. And so in the SLL, it doesn't matter because, or it does matter because if we have it pointing somewhere in this list that's not the head, we can't access the other things. Now let me ask you this. What if, I'm going to kind of move this over just a tidge. Move it over here just a little bit. Now let's pretend that this is looking like this. So of the things I've described in the notes today, what did I just make? Of all the linked lists that I've discussed today, what did I just make? See if you guys have been paying attention. I know I haven't been doing any coding, right? I've only done pictures and words. What did I just make though? What kind of linked list do you think this is? And the only thing I did differently was I added this. Attacker's right. I made this a circular linked list. So now I'll ask the same question. Let's imagine that this node here, this head node, is now pointing at the same element I said before. Is there any way that we can get to 0x0a? What do you guys think? Cherry, you're even more correct, right? It's a circular single linked list. It's a circular singly linked list. Say that 5 times fast. Yes, there is a way we can get there, right? There is a way. We're just going to go here, 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 here. Now we're there, right? So now I just want to point this out in that if we did it this way, right? If we made this a doubly linked list, so let's pretend that I added all of these arrows, right? Might take me just a moment. But let's pretend I'm adding all of these arrows. So what kind of list is this? I just want to see if we can put it together in our heads, right? What kind of list is this? That's a DLL, right? That's a doubly linked list, right? So let's pretend I have a pointer here. I know I'm asking some goofy questions, but I'm just making sure, as always. Can I get to 0x0a from here? If the head node is pointing at that second element, can I get to 0x0a? Yes, right? And then this one's going to be the easiest one. This one's going to be the easiest one. So finally, what is this one? What did I just make? What is this one? What is this one that I made? And I won't ask you the final question. I know that you know that I'll ask you. But what did I just make? That's a circular DLL, right? And obviously we can get to every node in here from any node. So now I'll ask this question. Of all the linked lists, well, I can't. Well, yeah, whatever. Of all the linked lists, which of them need a head node to always look at the first node? This is a test question, guys. Of all the linked lists, which of them need a head node to always look at the first one? Now, I already gave you this one, right? Obviously, this one here, right? But I want to hear. It's only the SLL, right? All of the others, it doesn't matter. All of the others, it doesn't matter. All right? So it is just the SLL, the non-circular SLL, if you would like to be specific. But usually I just call that an SLL. I'll put it in parentheses, though. So you guys are on board, okay? You guys are on board with me so far. So maybe I'll add just a little bit down here in the DLL. And we will have just a little bit more notes to add on Tuesday. But for now, we're going to leave it at that. So let me go save this where I want to save it. And then I'm just going to do a small whiteboard with the code. It always looks at the very first. Well, the answer is yes, Cherry, if it's a good one. You can write the code if you want. That will not work that way, but it will be bad code. What kind of memory problem do you think we have if we have an address that can't be reached? What kind of memory problem do you think we have if there's an address that cannot be reached? A memory leak, right? That's exactly right. That's what happens. So assuming that this was a single LL and we were pointing at not the first element, we would have a memory leak. We would have a memory leak on this node. This node cannot be reached. Therefore, it's a memory leak. So yes, to answer your question, Cherry, if you want good code, the answer is yes. If you don't care that your code has memory leaks in it, then no, it doesn't, if you don't want it to. But I would recommend it. So I'm actually going to just kind of open up some code. We'll see if we actually get to the whiteboard part of it today. But we're just going to start by coding up an actual linked list, how it works. Now I'm going to wrap it in a class, all right? I'm going to wrap it in a class because we've been dealing with classes all the time, all right? So we'll just call this our SLL.cpp, and we'll kind of work on it a little bit. I'm going to wrap it in a class, though. I could make it work without a class if I wanted to, but I really don't see any valid point to do that. Unless we had all the time in the world. Let's make it a template, too. What do you guys say? So let's make a template dynamic array called SLL. So we're going to have a type name here. Let's call it T. And we're going to call it class SLL for singly linked list. Now up here in the global scope, I'm going to declare a node. Look what we're using here. Wow, structs. It's been so long. Now I'm going to make this a template type as well. The node is an element. So this code is always consistent, all right? I'm going to put this in our notes. This is one element in the list. All right. And so what it's going to have is it's going to have some data, t data, and then it's going to have a pointer to the next node. All right, so if we look at our Excel sheet, the number is t data, and the address, or this arrow rather, this arrow is the pointer here, node next. Now this is always the case for SLLs, all right? This is always how it's going to look, pretty much. No, not pretty much. That's always how it's going to look. I guarantee it. Just like Men's Warehouse. All right? There you go. So that goes in there. So in our SLL, let's have a few private variables. The first thing I'm going to have is a node, head node. This is the head of our list. And then I'm having an int for the size. All right? I'm going to initialize them because I always like to do that, since we're dealing with some memory here. Now we're going to have to do a few things here. Of course, we're going to have to do the rule of 3, but we're not going to get to that today. So we're going to have to kind of come back to it later. But we'll see how far I can get in these 4 minutes of just kind of adding some things. So while I'm doing this, if you've got questions about what we talked about today, please let me know so I can answer those. So I'm going to do a default constructor. This one's going to be super easy. I'm just going to initialize our SLL to be null pointer inside 0. Now, of course, if we're going to do the rule of 3, we are going to need a destructor for our SLL. We're going to need a copy constructor for our SLL, const SLL and we will need an operator overload for our SLL. So we'll kind of work on those next time. I'm going to add a few member functions. Some of those will be, let's do a clear list function. All right, so we'll clear our list. Let's do an insert function. And we may do a delete, but our insert function will take some t data, right? In fact, we're going to do 2 of them. We're going to do an insert at the head. We'll call it push front. How about that? Push front. And then we'll do push back. Push front, we'll put it at the front. Push back, we'll put it at the back. All right. So we'll kind of work on these next time. The easiest one we can do right now is the void pushback, so I might just kind of cram it in here real quick. I'm going to kind of course, speed run this as I do occasionally. So if we're going to do the push front function, there's a few things we need. For one, it's a template, right? So I can't forget to bring it down. The next thing I need is the scope resolution operator. This resolution operator here needs to have the template type attached to the singly linked list. Say we're going to insert t item, and this will put the element at the beginning of the list. So very easily we can do it like this. We can make a node pointer, new node is equal to new node, and then we're going to say new node data is equal to item. And then I'm going to say new node next is equal to the head of the list. And then I'm going to say the head of the list is now equal to the new node. So next time we'll come back and talk about this a little bit. All right. So I know that that was probably a little too much for our heads right now. But we will come back next time and talk a little bit about this. And we're going to start working with our linked lists, all right? Thank you all very much for coming to class today. I'm sorry that I'm so disorganized. This is kind of a fast-paced class, even for me. So I'm doing my best. So I have a few things I need to do. One of those is I'm gonna edit your assignment 6 PDFs and re-upload it just to add a little more detail in there. Hopefully the operators, as you guys have said, helped you out today. You'll be able to get that done. Assignment 7 code grade will be going up sometime today or maybe tomorrow. Depends on how fast I'm working. So look for that. Assignment 8 will be uploaded today. All right, that's going to be your recursion assignment. That one will be teeny tiny. Just solve some problems recursively. So I'm going to be working on all of that for you guys. So look out for those announcements. Ask me questions if you need. I'm here for you. Assignment 6 is getting pushed back another day. All that good stuff. So once again, thanks for coming to class. Happy 4th of July to all of you. I hope you guys have a great Friday. I hope you guys have a great weekend. Message me if you need. You guys make my day, all that good stuff. I'll see you guys next time. Thanks for coming. You're welcome, Cherry. You're welcome, Attacker. You're welcome, Chowder. You're welcome, Allie. You're welcome, Coda. Of course, thank you all for coming to class today.